Good morning and welcome back to Dr. Logic Awkwardly Does Logic, where today I will show you what frame condition the axiom B corresponds to, and then say a little bit about what this has to say in general about the frames that system S5 have. Because remember, we've given you two different axiomatizations of it. I've told you that they're equivalent. I've partly proven that they're equivalent. And now I'm going to give you another way of seeing that they have to be equivalent. But let's start off with first. Me get all of my kits sitting flat so I can actually write on it. Let us start with actually doing the correspondence between the axiom, the B axiom, which is if P is true, then it is necessarily possibly true. And this is going to correspond to the frame condition of symmetry, which says for all worlds X and Y, if X sees Y, then Y sees X. So what we're going to show is the usual kind of correspondence result. A frame F validates this axiom if and only if the frame is symmetric. So this is a biconditional. We need to prove both directions. I'm going to start with the right to left. So assume the frame is symmetric and then show that the formula has to be valid on it. So assume F is symmetric. Now we want to show that P implies necessarily possibly P is always true. We will do this by reductio, and we will assume, for the sake of a contradiction, that the axiom is not valid. This means that there is a model based on this frame and a world in that model where the formula is false. So P does not imply necessarily possibly P. So let's just, instead of writing out all of the definitions, let's begin to build the model. So we have this world. Let's call it W, and at this world, by assumption, P implies necessarily possibly P is false. This is a conditional. That means that the antecedent is true and the consequent is false. Now, in order for a necessity claim to be false, there has to be some world that it can see where the bit that's supposed to be necessary is false. So what we've got is possibly P has to be false at W prime. Now, this isn't ordinarily a problem because who knows what W prime can see? Except, remember that we are assuming that the frame is symmetric, so W prime can see W, but P is true there. This means at W prime, P is possible. And look at that, we have our contradiction. It can't be the case that possibly P is both false and true at W prime. So that is the right to left direction. Let's erase this so that I've got a bit of space in order to do the other direction. This is the direction that is a little bit harder, but we've seen these proofs often enough that hopefully they are beginning to become somewhat second nature. So now what we're going to do is we're going to assume that we have a valid frame that validates this axiom, and then we need to show that it is symmetric. As usual, we'll do this contrapositively. So we're going to take a frame that is not symmetric. So symmetry fails. This means that we have many possibilities of how the frame could look, but we know that we, have two worlds, W and W prime, where W sees W prime, but not vice versa. This is just the definition of what it means for a frame to fail to be symmetric. Now, we will build a model build a model on F that falsifies our axiom. So what we are doing is we are going to show that if it's not symmetric, then it doesn't validate the axiom, which by contraposition means that if it does validate the axiom, it has to be symmetric. Now, think back to what we just saw in our right to left version, where essentially the problem came from the fact that W prime could C back to W where P was true. What we want to do is define a model that makes the axiom false at some world. It's going to be P. So we know that P has to be true at W. So the value of P at W equals true. Now, in order to make this false, it has to be the case that there is at least one world that W can see that sees no worlds that make P true. So of course, we're going to use our W prime here. So we will set the value of P at any world W2 prime to be false if W2 prime is accessible from W prime. And then all other parts of the valuation are going to be arbitrary because it won't matter. What we've got here is a world where P is true, a world that it sees where we don't know what it sees. It could see itself, it could see lots of other things, it could see nothing. The point is, at any one of these worlds that it might see, P is false at all of them. And that means that possibly P will be false here, and necessarily possibly P will be false here, which is what we need in order to show that this non-symmetric frame doesn't validate the axiom. So this is a general model that you can use on top of any non-symmetric frame. There you've got your correspondence result. Next time we will look at how this intersects with the correspondence results for the T axiom, the 4 axiom, and the E axiom. All of the different parts that go into our the construction of our frames. So join me again then, and I hope to see you soon. Take care.